Hello everyone, I am Dr. J.S. Naveen Kumar, Dean of the Department of Data Science at Malla Reddy University. It is my privilege to address you at the start of your journey in one of the most progressive and dynamic fields today, data science. The world we live in is driven by data. Companies, governments, organizations are seeking experts who can transform raw data into meaningful insights, guiding them toward better decisions and innovations. At Malla Reddy University, we are committed to helping you become these experts. Our department boasts a team of highly skilled and experienced faculty, industry resource persons, and access to world-class infrastructure, the latest software and professional tools. All these resources are dedicated to supporting and mentoring you throughout your data science learning path. This session is designed just for you, our aspiring data scientists, to launch you with the right knowledge, direction, and sense of purpose in this exciting in-demand field. Get ready to explore, innovate, and lead. Welcome to the future of data science at Malla Reddy University. Before we dive into the main content, let's take a moment to understand why data science is such an exciting and important field today. We are surrounded by data everywhere, every time. We browse Instagram, stream a video on YouTube, shop on Amazon, or even make a UPI payment. We are generating massive amounts of data. But here's the real question: what happens to all of that information? How do business and organizations make sense of it? For example, imagine you buy a pair of running shoes online. The very next day, you might notice suggestions for energy bars, fitness watches, or running socks. That's not a coincidence. That's a data science quietly working in the background, analyzing your purchase patterns and predicting what you might need next. We'll see another example. The same thing happens with Netflix recommending your next show, banks detecting unusual transactions to prevent fraud, or hospitals predicting disease risk. Data science is all about turning raw data into powerful insights that shape our everyday experience. So in this presentation, we are not just going to define data science, we are going to explore the essence, the skills it requires, the ethics behind it, the real world roles it creates, and the opportunities it opens for your future. By the end of this session, I hope you will see data science not just as a subject to study, but as a journey of discovery, innovation, and impact. Here, a quick overview of what we will be covering today. We will begin with data science and then move into why it really matters in today's world. From there, we will dive into the essence of data science and discuss the role of ethics in data science. We will also look at the key skills every data professionals needs and walk through the data science lifecycle. Then we will explore the core components and the major tools and technologies used in this field. After that, we will see how data science applies across different industries and learn about the real world roles and career paths it offers. For those starting out, we will share tips for beginners and outline course expectation for aspirants. Finally, we will wrap up with a conclusion and a motivational note to help you see how data science can shape your future. What we explore in this session, now that we have seen the contents, let's look at the bigger picture of what we will covering in this presentation, the data science landscape. See, we will start with the beginner challenge that newcomers usually face, and then move to the data science roadmap, which helps us understand how to plan and approach projects strategically. Next, we will explore the real world roles in data science, followed by the data science life cycle, which explains the stages of working with data. From there, we will discuss the importance of ethics in data, ensuring responsible use of data, and then move to the job opportunities available in this growing field. Finally, we will wrap up with course expectation, giving a clear idea of the academic preparation required to pursue a career in data science. So, this slides acts like our roadmap, showing us where we are headed in today's session. The main question, what is data science? Data science is the field where mathematics, statistics, and computer science come together to make sense of data. It's not just about collecting numbers. It's about cleaning, analyzing, and interpreting data so that we can solve real-world problems. Think of it like this. Raw data is messy, like puzzle pieces scattered on a table. A data scientist's job is to fit those pieces together to see the bigger picture. Whether it's predicting customer behavior, improving healthcare treatments, or helping cities become smarter. You can imagine a data scientist as a detective, looking for clues hidden in the data to find answers that matter. In simple words, data science is the art and science of turning data into decisions. Turning data into decisions. This is the simple definition for the data science. So, data science is all about turning data into decisions that help business grow, improve healthcare, enhance customer experiences, and even drive scientific discovery. Let's begin with the most fundamental question, what is data? In simple terms, data is nothing but a collection of raw facts, figures, or symbols. These could be numbers, text, images, videos, or even sounds. On its own, data doesn't always carry meaning. It needs to be processed, analyzed, or interpreted to become useful information. In computing, data is stored digitally. In this raw digital form, in computing, data is stored digitally in the form of binary code, ones and zeros. From this raw digital form, it can be organized in different formats like files, spreadsheets, or databases so that it can be processed more effectively. Now, data comes in different types. Broadly, we classified it into two types, structured data and unstructured data. Coming to structured data, organized in rows and columns like what you see in databases or Excel sheets. Coming to unstructured data, things like videos, social media posts, or images which don't fit neatly into tables. This is called as unstructured data. So now we have to discuss about why data science matters. Data science truly matters because it gives business the power to make smart data-driven decisions that lead to real growth, greater efficiency, and exciting innovation. By digging into massive data sets, it uncovers valuable insights that help companies stay ahead of market trends, better understand their customers, and fine-tune their operations often in real time. It's like having a crystal ball but backed by data. Now we'll see essence of data science. You can understand the essence of data science in a few simple ways. See, one of the things, data abundance. We live in a world overflowing with information from clicks and purchases to sensor readings. Unlocking secrets. Data becomes meaningful when we discover hidden patterns and insights. High demand. Skilled data scientists are highly sought after across industries, helping organizations make better decisions. Future fuel. Data is powering innovations of tomorrow, from AI to personalized healthcare and smart cities. We'll see one example to understand about the essence of data science. Imagine a city using traffic sensor data to predict congestion and optimize traffic lights. In this one example, you can see how abundance, insights, demand for expertise, and future impact all come together. Data is everywhere. Data science is the lens that makes sense of it. See, this is the quotation, data is everywhere. Data science is the lens that makes sense of it. So, data science is not just a technical skill. It's a tool to create real world impact. Anyone who can understand and use data effectively can help organizations, communities, and even countries make better choice. We'll discuss about ethics in data science. Before we move on to the skills you will need, let's pause for a moment to think about responsibility. With great power comes great responsibility. Data is not just numbers, it's represent real people, their habits and choices. As data scientists, it's crucial to use ethically. Now we'll see different type of ethics. Protect privacy. Respect the information of individuals. Avoid bias. Ensure algorithms are fair and inclusive. Use data for good. Insights should help solve problems, not create new ones. We'll observe one example. Imagine an app recommending jobs. If it unintentionally favors some applications over others, that's unfair. Awareness of ethics helps prevent such outcomes. Ethics is the foundation of data science. Powerful insights are only meaningful when used responsibly. Now we will see key skills for data science. Data science is a mix of technical knowledge, analytical thinking, and creativity. Here are the most important skills are. One of the skill is mathematics and statistics. See, understanding numbers, probabilities, and patterns is fundamental. These are the fundamentals for the mathematics and statistics. We need to understand numbers, probabilities, and patterns in fundamental. Next step is programming. Languages like Python or R programming help you work with data efficiently. Next thing is data handling and databases. Knowing how to collect, clean, and organize data is crucial. Next step is data visualization. Presenting insights clearly using charts and dashboards helps others understand your findings. Machine learning and modeling. Building predictive models lets you solve complex problems. Next thing is critical thinking and problem solving. It's not just about tools. Knowing what question to ask and how to approach it is key communication. Last step. Communication and storytelling. Explaining your insights in a clear, actionable way is just as important as finding them. Even if you are beginner, you don't need to master everything at once. Start small, focus on one skill at a time, and gradually build your experience. Tools make the work easier, but skills make you unstoppable. Now, with these skills, we can observe the data science life cycle. See, this slide explains the data science life cycle, the journey that every data science project follows. The first step is concept study. Everything begins with understanding the problem. What exactly are we trying to solve? For example, an e-commerce company may ask, can we predict which product a customer is likely to buy next? Clearly defining the objective is the foundation. This is the first step of concept study. That means indirectly it is a problem statement. Second one, data preparation. Once we know the problem, we collect and prepare the relevant data. This involves cleaning, removing errors, and formatting it for analysis. For example, customer purchase history may have missing values or duplicates, which must be handled before analysis of customer history. Next, model planning. In this stage, we decide the best approach to solve the problem. Should we use regression, classification, or clustering? For instance, to predict product recommendations, we might choose collaborative filtering models. Planning ensures we use the right methods. The fourth one is model building. Here, we actually train the machine learning models using the prepared data. For example, a fraud detection system may be trained on millions of past transactions to identify suspicious ones. This is where the real magic happens. The last step, communicate results. Finally, the results are interpreted and shared in a way that decision makers can act upon. This could be in the form of dashboards, reports, or visualizations. For example, a bank may receive a real-time fraud alert system, or an e-commerce company may get an easy-to-read dashboard of customer buying patterns. So, in short, data science lifecycle takes us from a simple idea to powerful solution that drives real-world impacts. Next, we'll see core components of data science. Let's explore the core components that make up this field, the building blocks you will work with every day as a data scientist. You can think of data science as a combination of three main components. One is data, the foundation of everything. Without data, there is nothing to analyze. This includes structured data and unstructured data. Already we discussed structured data like spreadsheets, unstructured data means text, images, or videos. The second tool, algorithms and models. These are the methods we use to find patterns, make predictions, and generate insights. Machine learning and statistical methods are key tools here. Third one is technology and tools. From programming languages like Python and R to databases, visualization tools, and cloud platforms, these make it possible to handle large data sets and turn analysis into action. Now we will take an example and discuss about what are the core components of data science. Imagine analyzing customer reviews for a product. You would collect the reviews. So whatever reviews you collected, that is in the format of data. This is the first tool. Use natural language processing, that is a algorithm or model, to understand sentiment and visualize trends using the charts or dashboards using the technology and tools. So data science is not just numbers. It's a combination of data, logic, and technology working together to solve the problems. Now that we know the core components, let's see the tools and technologies that make data science projects possible in the real world. So, tools and technologies in data science. Now that we understand the core components of data science, let's explore the tools and technologies that make it all possible. Data scientists rely on a mix of programming, data handling, visualization, and machine learning tools to turn raw data into insights. Here, the main categories are programming languages. See, in this presentation, many times I mentioned the foundation or basic thing is to learn about the programming language like Python and R are the most popular. Python is widely used for data manipulation, analysis and machine learning, while R is strong for statistics and visualization. The next tool is databases and data storage. SQL, NoSQL and cloud databases help you store, retrieve and manage large data sets efficiently. The third one is data visualization tools. Tools like Tableau, Power BI and Matplotlib help you present insights in clear interactive charts and data and dashboards. Next thing is machine learning and AI frameworks. In machine learning and AI frameworks, libraries like scikit-learn, TensorFlow and PyTorch allow you to build predictive models and intelligent systems. The last one is big data and cloud platforms. Big data and cloud platforms technologies like Hadoop, Spark and AWS enable you to process massive data sets and deploy models at scale. For example, imagine analyzing social media data to see trends in user behavior. You would use Python to process data, SQL to fetch it from database, scikit-learn to build a model and Tableau to visual the results. So what you observed, we are using the combination of programming language, databases, data visualization, ML and AI frameworks, and finally we deploy in the big data platforms and cloud platforms. So tools are the hands, skills are the mind. Together they create the magic of data science. With the combination of tools and skills, we can create the magic of data science. With a clear understanding of the tools, let's now see how data science is applied across different industries in the real world. So we'll see different type of applications across industries. Data science applications. Now let's see the way data science is actually used in the real world. Data science is everywhere. You encounter it in many industries, often without even realizing it. One of the application is IT and software. Recommendation system in Netflix, YouTube or e-commerce sites suggest what you will like next. Spam filters in Gmail or fraud detection in online transaction also rely on data science. One more application is finance. Banks use it to detect fraud, predict market trends, and guide investments. Financial institutions analyze large data sets to make smarter, faster decisions. We'll see one more application, very broad application is healthcare. Hospitals and labs use data science to predict diseases, personalized treatments, and even save lives through early detection. And one more application we'll see, retail and e-commerce. In retail and e-commerce, understanding customer behavior, optimizing inventory and personalizing offers are all powered by data science. And one more application, sports and entertainment. Teams analyze player performance and strategies, while platforms study audience engagement and trends to improve experiences. And we will see one more application, smart cities and government. Smart cities and traffic management, energy optimization and public policy decisions are increasingly data driven. So these are the applications we discuss in the data science real world applications. Think about which industry excites you the most. How could you use data to make a real impact there? Even imagine it helps you start thinking like a data scientist. Data science is not limited to one field. It's a tool that transforms industries and touches lives. Having seen how data science is applied across industries, let's talk about the different career paths you can take in this field. See, roles and career paths. Real world roles and career paths, or we can call as job roles in data science. This slide outlines the key job roles within the field of data science, each with distinct responsibilities and required skills. Understanding these roles helps define a career path and build the right competencies. The first job role we'll discuss is data scientist. Coming to this data scientist job role, extracts insights from data using advanced analytics, machine learning and statistical models. So to achieve data scientist job role, what are the key skills are required? The first key skill, you should have the programming language like Python or SQL, and you should know about the technology of machine learning and AI, and data visualization with Matplotlib, Sevan, Plotly like that tools, and statistical analytics, big data tools with Spark, Hadoop like that, communication of complex findings. These are the key skills required to achieve the data scientist job role. So we'll see an example task in the data science job role. Build a recommendation engine for an e-commerce site. This is a small example task for the data scientist. We'll see another job role, data analyst. Data analyst job role interprets data to find trends and generate actionable insights for business decisions. To achieve the data analyst job role, the minimum required key skills are: you should know about Excel, SQL, data visualization with Tableau, Power BI, basic statistics, business intelligence tools, reporting and dashboards technology. These are the key skills required to achieve the job role of data analyst. So we'll see one example task of data analyst. Analyze monthly sales data to identify best performing regions. This is an example of example task of data analyst. So now we'll see the third job role, data architect. Coming to data architect job role, designs and maintains the data infrastructure, ensuring data is well structured, accessible and secure. Now we'll see what are the key skills required to achieve the data architect job role. Database design is required, data modeling is required, ETL process is required. ETL process stands for extract, transform and load. Cloud platforms required means AWS or Azure or GCP, that means Google Cloud Platform. Data governance and security, these are the technology and the skills required to achieve a job role of data architect. So now we'll see an example task of data architect job role. Design a scalable data warehouse for enterprise level analytics. So this is a small example task of data architect. Now we'll see the another job role, data engineer. So coming to data engineer job role, builds and optimize systems for data collection, storage and processing. So now we'll see what are the key skills required to achieve the data engineer job role. So the first key skill is programming. Already we discussed Python, Scala, Java, these are the programming skills required. Data pipelines required, distributed systems means Hadoop, Spark, ETL development and cloud services like AWS, Glue, Google, BigQuery. These are the skills and technologies required to achieve the job role of data engineer. So now again we'll see one example task of data engineer. So build a real-time streaming pipeline to process IoT sensor data. This is an example task for the data engineer. So we'll move to another job role, statistician. Applies mathematical theories and statistical techniques to collect, analyze and interpret data. This is the role of statistician. To achieve this statistician job role, the required key skills are statistical modeling, hypothesis testing, experimental design, or SAS or SPSS, programming languages, mathematical optimization. These are the skills required to achieve the job role of statistician. We'll see an example task of statistician. Determine the confidence level of a new marketing campaign's effectiveness. This is an example of statistician job role. Now we move to database administrator. Coming to database administrator job role, manages and maintains databases, ensuring performance, integrity and security. Now we will see what are the key skills required for database administrator. SQL and database query optimization, backup and recovery, performance tuning, security management, Oracle, MySQL, PostgreSQL, etc. These are the skills required to achieve the job role of database administrator. So this is the role of database administrator. So the primary and important job skill is databases. So we'll see an example task for the database administrator. Ensure 24/7 availability and backup of a transactional customer database. Next, we'll move to another job role, business analyst. Coming to business analyst job role, bridges the gap between business and data teams, focusing on using data to improve business outcomes. So now we'll see the key skills required to achieve the business analyst job role. Requirement gathering, data interpretation, communication stakeholder management, business analytics. Coming to business analytics, you need to know about Excel, SQL and Tableau, and domain knowledge, example, finance, healthcare, like that. Next, we'll see the example task for the business analyst. Recommend product changes based on customer feedback and sales data. This is a small example task for the business analyst. Now we'll see one more and the last job role in this slide, data and analytics manager. In this job role, leads data teams, manages projects and ensures data strategies align with business skills. Next, we'll see what are the key skills required for achieving the data and analytics manager. Team leadership skill is required, project management is required, data strategy is required, and budgeting the stakeholder communication, hands-on understanding of data tools. These are the skills and tools required to achieve the data and analytics manager. So we'll see one example task in this job role. Oversee the implementation of a company-wide analytics platform. So finally, I want to give a tip to aspirants. Choosing a role depends on your interest and skills. Some may enjoy coding and modeling, while others may thrive in interpreting data or guiding business decisions. In data science, there is a role for every curiosity and skill. Find your path and start shaping the future. Now that we have seen the roles you can aim for, let's talk about how to get started as a beginner in data science. So, as a beginner, how to get started? This is we will discuss. Tips for beginners. Starting can feel overwhelming, but the journey becomes manageable if you follow a few simple steps. First step is start small and build foundations. Focus on basic programming languages, maths and statistics. Even small daily practice matters. Next, hands-on practice. Work on mini projects or data sets to apply what you learn. Real experience is the best teacher. Next, learn to handle data. Practice collecting, cleaning and exploring data. This is where you turn theory into real skills. So, the important skill is learn to handle the data. Next step is use free resources. Online tutorials, forums, videos and blogs are invaluable. You don't need expensive tools to start. You can use the whatever open sources, online sources available. Those sources you can use to build your data science projects. Next and last step, collaborate and ask questions. Discuss with peers or mentors. Every question opens a new perspective. Interactive thought. Pick one small project idea, maybe predicting your own weekly study time or analyzing daily steps. Start simple and you will build confidence quickly. Persistence is your superpower in data science. Every small step today build your expertise for tomorrow. Now we'll see the conclusion and motivation. As we come to the conclusion of this presentation, let's take a step back and reflect on the journey we have covered. We began by understanding what data science is and why it matters. We explored its essence, the life cycle, the tools and technologies, and how it creates value across industries. We also discussed the importance of ethics, the key skills required, and the various career paths it opens up. The takeaway is clear. Data science is not just about numbers or coding. It's about discovering insights, solving problems, and driving decisions that shape the future. And here's my message of motivation for all of you. Every great innovation begins with a single question. In data science, curiosity is your most powerful tool. Don't be afraid of the complexity. Start small, keep learning, and be persistent. Remember, one data set, one model, or even one creative idea could be your one chance to make a real impact. So stay curious, stay motivated, and step forward with confidence into the world of data science. Thank you all for your time and attention throughout this session. I hope this presentation has given you clarity on data science. Thank you once again.